Welcome to homework.
Chapter 16, problem 64 from the textbook Chemistry, the Essential Science. The question's asking us to calculate the percent ionization of a propionic acid, which is C2H5COOH, and solution for each of the following concentrations. So we're going to do problem A, when our initial concentration is 0.250 molarity. So the first thing we have to do is write out our equation for this acid and how it dissociates. So the acid is going to lose a proton, and we're going to have C2H5COO minus. All of our substances are aqueous. And now we're able to write an ice table off of this to be able to find our unknowns over here. And so we know we started off with the 0.25 molarity, and we didn't have any starting concentration of these two items. And since we had only a starting of this, we're going to subtract from here, and then we're going to add the same amount to both sides. And at equilibrium, we just add up the two lines before. Now we use our Ka equation, which is just our products over reactants. So in this case, it's our H plus concentration plus our C2H5COO minus concentration all over our C2H5COOH concentration. And we're going to plug in our values that we have in our bottom equilibrium line. Since our number is a large number in the front and our Ka is a small number, the x is going to be insufficient, so we can just not worry about that x when we're trying to solve for x in the overall equation. So that's the hassle. We don't have to use the quadratic equation to solve for x. And so now we have our Ka, which I found in the back of our textbook. And so now all we have to do is solve for x. So we have x squared is equal to 1.3 times 10 to the negative fifth times 0.25. And then you just take the square root of both sides to solve for x. And our x is equal to 1.8 times 10 to the negative 3. And so this is our H plus concentration. So the question asks for percent ionization, and percent ionization equation is your concentration ionized, so your H plus over your original concentration. So we have our H plus concentration, which is 1.8 times 10 to the negative 3 over 0.25. Then you multiply that by 100 to get your percentage. And when you plug that into your calculator, you get 0.721% is our percent ionization. So B, we're doing the same exact thing that we just did for A, but we're now changing our initial concentration for our equation. So we're going to have our C2H5COOH go to H plus C2H5COO. This is aqueous. So this is going to be 0.080000, and then you subtract x plus plus x, and then you have 0.0800 x, and then you're subtracting x here. And in this case, again, our Ka value is a lot smaller than our initial starting concentration, so our x is insufficient when we're doing our Ka value. So we're just going to do Ka with our products over reactants again. And so we have our H plus over our C2H5COO all over our C2H5COOH concentration. Now we plug in the values we have for that. In 1.3 times 10 to the negative 5, and then you solve for x. You take the square root from both sides, and we get x is equal to 1.019 times 10 to the negative 3. And then we're going to do the same thing for percent ionization. Where it's our amount ionized, which is 1.019 times 10 to the negative 3 over our initial concentration times 100. And our percent ionization is 1.27%. All right, our last question, part of this question, is the same thing, just at another smaller, at a smaller value for the initial concentration once again. And so what we're going to be doing is the same thing. C2H5COOH is then ion split up into our C2H5COO minus plus our H plus. And then we add our initial concentration here, and then 0, 0. Then we subtract our x, add, and add. And once again, our starting material is higher than our K value significantly, and so it's going to be negligible, and so we don't have to include it whenever we write our Ka equation. And so I'm going to skip the step of writing out our Ka over our products over reactants because we've done it 3 times now. And we can just solve for our x value. And then we're going to take the square root of both sides, and x is going to equal to 5.1 times 10 to the negative 4th. And then find our percent ionization. We are going to just do our ionized component, so 5.1 times 10 to the negative 4th, all over our initial amount, which is 0.02 times 100, and our percent ionization is 2.55%.